There are certain times when we need to perform a long division on polynomials in algebra, similar to the long division that you used to perform on numbers in arithmetic. Okay. This procedure is best illustrated by an example. Let's start by working out the problem x squared plus 5x plus 6 divided by x plus 2. Now, I've picked this particular example because this particular problem can be done by factoring and canceling. Okay? That doesn't mean all problems can be done by factoring and canceling and you don't need long division. I've picked a problem that can be done another way so that we can compare our answers and see that the new method seems to be correct. Okay. Now, to factor the numerator in this particular problem, we look for two numbers that multiply to 6 and add to 5. And they, of course, are 2 and 3. The numerator is x squared plus 3x plus 2x. That's plus 5x plus 6. Okay, divided by x plus 2. We can factor. We see that x plus 2 is a factor in common in the numerator and the denominator. We can cancel the x plus 2's. That is, divide numerator and denominator by x plus 2 to get a final answer of x plus 3. Okay, and I'm going to use long division on this same problem. To find x squared plus 5x plus 6 divided by x plus 2, we'll get the same answer, x plus 3. Of course, the importance of long division is for problems where you can't just factor and cancel out. Okay, now I want to remind you how you did long division in arithmetic, so you can carry over the same ideas into algebra. Let's say we wanted to figure out 225 divided by 3. Okay? This would mean 3 into 225. Okay? 3 doesn't go into 2. 3 into 22 goes 7 times. And then we multiply 3 times 7, get 21. And then we subtract. Okay? 2 take away 1 gives us 1. 2 take away 2, 0. And we bring down the next number, 5. Then we go 3 into 15. 3 goes into 15 5 times. 5 times 3 gives us 15. We subtract, remainder 0. So 225 divided by 3 is equal to 75. Okay, we're going to carry over this idea into this particular problem. We want to figure out x squared plus 5x plus 6 divided by x plus 2. Okay, so we're going to put x plus 2 into x squared plus 5x plus 6. Now, two things that are very important in a long division problem. Okay, number one, okay, you want to divide x squared plus 5x plus 6 by x plus 2. Okay, what you want to divide in this particular problem, okay, must be written in descending order. The terms, okay, of the polynomial must be written in descending order. That is, first we have the term of degree 2, then the term of degree 1, and then the constant term. Okay, so write them in descending order from highest degree to lowest degree. Okay, also, we have to make sure that there are no terms missing. For example, if this had just been x squared plus 6, I would have to leave place for the x term. Okay, you can either leave it blank or you could write 0x. Okay, in there. We'll see examples of this later on. But it's very important that we write the polynomial that we want to divide. Okay, we write it in the terms in descending order of degree, and also that we have place for every degree from highest to lowest. Okay, now, in the same way, look what we did over here. We said, how many times does 3 go into 22? 7 times. Then we multiplied, then we subtracted and brought down the next number. We're going to follow the same kind of procedure here. We're going to look at the first term here, x, and the first term here, x squared, and say how many times does x go into x squared? Well, of course, x goes into x squared x times. Okay, then we will multiply. Okay, we will multiply x by x plus 2, not just by the x, but by the whole thing, x plus 2. Using the distributive law, x times x gives us x squared. X times 2 gives us 2x. Okay? X times x gives us x squared, x times 2 for 2x. And just like we did in arithmetic, we will subtract at this point. Okay, now, x squared, take away x squared, this goes, that just gives you 0. 5x, take away 2x, gives you 3x, and you then bring down the next term. Okay, at this point here, we are subtracting. Okay, now if you can do that in your head, fine. X squared take away x squared, that's 0. 5x take away 2x, that's 3x. If not, you can always remember that subtraction means you add the opposite. So you can say instead of plus x squared, you can say change that to minus x squared and add. Change the plus 2 to a minus 2x and add. Okay, of course, x squared and a minus x squared gives you 0. 5x and a minus 2x gives you the same 3x. So if you can do it in your head, fine. If not, feel free to, in other words, circle or cross out the signs that were there. Change the signs to the opposite and add. Okay, now we've subtracted. We now bring down the 6, and we repeat the procedure. How many times does x go into 3x? X into 3x. Okay, well, 3 times. 3 times x is 3x, okay? We have to multiply the 3 times the x plus 2, once again by the distributive law. 3 times x gives you 3x plus 3 times 2, which is 6. And we subtract. The 3x's cancel each other out, and the 6's cancel. Remainder 0. And we see that the answer to the long division problem, x squared plus 5x plus 6 divided by x plus 2 is x plus 3. The same answer that we got over here when we factored and canceled. And this is not too surprising. If you do a problem by 2 different methods, you should get the same answer. Okay, but you must realize that you can't always factor and cancel. Okay, the long division is like a more general method for you. Okay, we get the same answer, x plus 3. In this case, we had over here. X plus 3 is the answer. Okay, now we want to work out x squared minus 4x plus 7 divided by x minus 3. Okay, now you're aware of the fact that not all division problems give you 0 remainder. Some don't work out evenly. Okay, let's try a problem in arithmetic. If I want to take 80 and divide it by 3, okay, 3 into 80. Okay, 3 into 8 goes twice. 2 times 3 gives me 6. I subtract, I get the 2. I bring down 0. 3 into 20 goes 6 times. 6 times 3, that's 18. I subtract, and I have remainder 2. So the answer here is 26 with a remainder of 2. Now what we can do is write the answer in a certain way. We can say 80 divided by 3 is equal to, let's move this over a little. 80 divided by 3 is equal to the quotient, 26, plus the remainder, 2, over the divisor, 3. Okay, this is how you can write your answer. Either 26 remainder 2, or in this technique, the quotient, 26 plus the remainder 2 over the divisor 3. Now 26 and 2/3 is the same as 80/3. It doesn't take very much to figure that out. 26 and 2/3. 26 and 2/3 is really 26 over 1 plus 2 over 3. The lowest common denominator is 3. Okay, to change 26 into thirds, we would have to multiply the denominator by 3. Therefore, we also multiply the numerator by 3. This gives us 26 times 3, which is 78 thirds, and then 2/3. And of course, we get the same answer, 80 thirds. Okay, I just wanted to convince you the idea of taking the quotient plus the remainder over the divisor does give you the correct answer. Okay, we do get 80 thirds, which was what we had over here. Okay, so this is a nice way of writing the answer to a long division. You can use this for algebraic problems as well, not just for arithmetic. A nice way of writing the answer to a long division problem is to take the quotient plus the remainder over the divisor. Now let's work out this problem over here. Okay, x minus 3 into x squared minus 4x plus 7. Okay, we are dividing into a polynomial. We are dividing a polynomial that has a second degree term, then a first degree term, and then the constant term. So it's in descending order, the degrees of the terms. Okay, and every term is accounted for from highest to lowest. We go x into x squared goes x times. X times x gives us x squared. X times minus 3 minus 3x. Now you must subtract. Okay, remember to subtract. We can change the signs of the thing we're subtracting and then add. This is really plus x squared. We can change that to a minus. The minus 3 we can change to a plus, and then we add. X squared and minus x squared, of course, gives you 0. Minus 4x and plus 3x gives you minus x. Okay, minus x, and then you bring down the next term, the 7. X into minus x goes minus 1 times. Minus 1 times x gives you minus x. Minus 1 times minus 3 gives you plus 3, and we subtract again. Okay? Once again, you can either do it in your head, minus x, take away a minus x, they cancel out, or you can change the signs and add. Minus x and plus x, that's 0. 7 and a minus 3, of course, gives you 4. And that's as far as you go. And we write the answer as the quotient, x minus 1, plus the remainder, 4, over the divisor, x minus 3. X minus 1, okay, what's up here, plus the remainder 4 over the divisor x minus 3. And if you were to algebraically add these, okay, combining over x minus 3, we would get the problem that we started with. X squared minus 6 divided by x plus 2. Okay, we're going to divide x squared minus 6 by x plus 2. But be very careful. We have an x squared term, a second degree term. We have the constant term. We must leave space for the first degree term, okay, the term of degree 1. Okay, there is an x term that's missing. Here's the second term of second degree, first degree, and then the constant. Okay, you can either leave it blank or put in a placeholder, 0x, to indicate that that is the x term. Okay, remember the two rules are write the thing you're dividing, okay, in descending order, and make sure you don't leave out any terms. Okay, then x into x squared goes x times x gives us x squared, x times 2, 2x. Then subtract. X squared and a minus x squared, that's 0. 0x and a minus 2x, that's minus 2x minus 6. X into minus 2x. Now when I say x into minus 2x, I'm looking for something which when I multiply by x gives me the minus 2x exactly. Okay? X times minus 2 would give me exactly what I want. So I say x goes into minus 2x minus 2 times. And I put the minus 2 in here. Minus 2 times x gives me the minus 2x. Minus 2 times plus 2 gives me the minus 4. We now subtract again, change the signs, and add. Minus 2x and plus 2x, that gives you 0. Minus 6 and plus 4, minus 2. And that's the remainder. So the answer to this problem is the quotient x minus 2 plus the remainder minus 2 over the divisor. The quotient plus the remainder over the divisor. Of course, there's absolutely nothing wrong with writing it in this form. Because after all, subtracting 2 over x plus 2 is the same as adding the negative. Okay, so either in this form, quotient plus remainder over the divisor, or just x minus 2, take away 2 over x plus 2. Okay, let's try some more. And of course, you can always try these problems on your own and shut off the videotape and put it back on when you're finished. Okay, 17x plus 12 plus 6x squared divided by 2x plus 3. Okay. The first thing to do, well, we want to take 2x plus 3 into this polynomial. We have to rearrange the terms. So the term of highest degree appears first. That's the 6x squared, then the 17x, and then the 12. We have to go from highest degree to lowest degree. So rearrange this for 6x squared plus 17x plus 12. Now, how many times does 2x go into 6x squared? And the answer is 3x times. Because 3x times 2x gives me the 6x squared. But don't forget, you also multiply the 3x by the 3. It's 3x times the 2x and 3x times the 3. This gives you the 9x. Okay, then you subtract. Okay, to subtract, we change the signs and we add. 6x squared minus 6x squared, that's 0. 17x and a minus 9x gives me the 8x. And we bring down the next term. Okay, the plus 12. How many times does 2x go into 8x? Well, 4 times. 4 times the 2x gives us the 8x. 4 times the 3 gives us the 12. And we subtract and just get 0, no remainder. Okay, so the answer in this case is simply 3x plus 4. No remainder. Of course, you could always check a division problem by multiplication. Whereas 12 divided by 3 is 4. You know you're correct because 3 times 4 is 12. Same thing here. This divided by this is equal to this. Okay, if when you multiply this by this, you get this answer. And multiplying 2x plus 3 times 3x plus 4 to see what we get. 2x plus 3 times 3x plus 4 using the FOIL method, first outer, inner, last. We get 2x times 3x, that's 6x squared. Outer, 8x, inner, 9x for the 17x. 3 times 4 gives you the 12. And of course, this is what we have up here, but in a slightly different order. 6x squared plus 17x plus 12. This is just a check. Okay, let's try one more example. X cubed minus 8 divided by x minus 2. Okay, that means x minus 2 into x cubed minus 8. In this particular problem, there are 2 terms that are missing. We have, starting with a term of degree 3, we must leave place for the term of degree 2 and the term of degree 1. Okay, there's an x cubed term, so we'll put in a 0x squared and a 0x, and then we have the constant term. Every term must be taken account of, okay, from the highest to the lowest. Okay, x into x cubed goes x squared times x gives us x cubed. X squared times minus 2 gives us minus 2x squared. And we subtract, okay? The plus x cubed is changed to a minus, the minus 2x squared to a plus, and we add. X cubed and a minus x cubed gives you 0. 0x squared and 2x squared gives you 2x squared, and you bring down the next term, which is 0x. X into 2x squared goes 2x times. 2x times x gives you the 2x squared. 2x times the minus 2 gives you minus 4x. We subtract again. Change the plus to a minus, change the minus to a plus, and add 2x squared and the minus 2x squared. They cancel out. 0x and 4x, that gives you 4x. Bring down the next term, minus 8. X goes into 4x 4 times. 4 times x. Take away 4 times 2. You get 4x minus 8. And when you subtract, of course, you just get 0. No remainder. The answer for x cubed minus 8 over x minus 2 is just x squared plus 2x plus 4. And that brings us to the end of this tape.